Okay, this is the first example which tells us how to design a milling fixture. So we know what a milling fixture is, or we know generally what a fixture is. A fixture is a production device which is used to hold and clamp the workpiece. It generally doesn't guide the cutting tool. Almost all fixtures, except I think the broaching fixture, because only the broaching fixture, apart from holding the workpiece, it also guides the cutting tool, especially the modern ones. Generally, fixtures are used only to hold and clamp the workpiece with respect to the cutting tool. And fixtures are usually used for larger workpieces, and it is fixed to the machine table as the name suggests. Okay, we'll see this example. So we're going to design a milling fixture to cut a slot of 3 into 3 mm. This question is not complete because the number of workpieces aren't mentioned. So these things we may, for example, in the exam you may be getting are the number of workpieces to be milled. So this question is not complete since I'm just showing this example for sake of the basic understanding of how you go about design a milling fixture. Okay, so this is the component. As you can see, it is given as the depth of the cut and the width of the cut is 3 mm. So if the number of jobs are mentioned in the question, see if it is more than one, generally we go for a string or a line milling fixture. So when the number of workpieces are strung behind each other in line, I repeat, if the number of workpieces are strung behind each other in line, then we go for a string milling fixture. So for this, as you can see here, you have the 5 workpieces. Example is shown here. 5 workpieces. If in case if in the question it comes as you have to mill say 3 workpieces, then we go for 3 V block locators. So in this case, they have assumed 5 workpieces. So we have they have used here 5 V block locators are used. As you can see, these workpieces are strung behind each other in line. So that's why this is called as a string or a line milling fixture. So the number of jobs are 5, and you can select these things from the design data book. What is the material is C45. Okay, the hardness value can be selected. So it's 229 HB, and these things may be selected from the design data book. Surface finish may be assumed of the locating fixture, and type of milling either can be down milling or up milling. Okay, so for the design procedure, this is the design procedure. First, the selection of the type of fixture. We have selected the line or the string milling fixture. Then selection of the locating method. We'll go for V block locators, and selection of the clamping method, and finally design of the fixture body. Okay. So the first one we have selected, that is selection of locating fixture is done. And we'll go for the second one, selection of the locating method. So V block locators are used. For this, we'll go to design page number 5.97. So this is the exact photocopy, 5.97. And generally the workpieces, see to come to the workpiece of 40 mm dia, a V block with D max 40 mm selected. So this is the D max value, 40 mm is selected. So corresponding values will be selected. A is equal to, see, A is the length of the V block locator, C is the height of the V block locator, and B is the width or the breadth of the V block locator. So 50, 40, C is equal to 40, D max is 40, D minimum is 5 mm. So this area, so this is the D minimum, and D max is 40 mm. So the corresponding values may be taken. A is equal to 50, B is 40, C is 40, and D max is 40, and D minimum is 5 mm. So this is the D minimum. So on which the cylindrical workpiece will be located. It will also be located in this V block locator as a whole. So this area will be touching the this portion of the V block locator. Fine. Now we'll go for the selection of the type of clamping method. So selection of clamping is also very important. And one more thing I would like to mention, in case if the question is a very short question, say for example the value that is given, the marks that is awarded is only 10 marks, then you can skip this portion, may be skipped. directly you can go for the selection of the type of pressure pad, or if it is specifically mentioned, for example, find the cutting force and the clamping force and the cutting force, then you have to work out this particular formula. That is you have to use this particular formula, that is 4.5 into K is the material constant K into F into D into B divided by CS, where the CS is the cutting speed and D and B values may be taken from this area, which I will be telling you, and K is the material constant. So these things can be taken from the design data book. That is K is equal to 8.5 kilonewton per mm square, and material constant for high carbon steel K. This is a fixed value. I think this you can memorize. And cutting speed may be assumed. Assume the feed is 75 mm per minute, and cutting speed CS is equal to 15 meter per minute. So this 15 to 10 power 3 mm per minute. And from this we can calculate what is the cutting force. So around 1721 was found out, and this B into D refers to 3 into 3, already is given in the sum itself. So this 3 into, that is B and D will be given in the problem itself. So it is easy to find what is the cutting force. The reason why we are finding the cutting force is because the clamping force must always be greater than this value. And the yield stress, sigma y for workpiece is 600. This can also be found from the design data book, page number 1.12. And the reason why we are finding is because we have to find what is the bearing area of the pressure pad A. So from this sigma y is equal to cutting force divided by the bearing area of the pressure pad. So from this since sigma y is known, cutting force is also known, we found out from here. So sigma y is 600. So Fc divided by sigma, which is equal to, so area may be found out. So it is 2.86 mm square. See, this portion, I repeat, can be skipped if the question is, if the marks awarded for the question is 8 marks or 10 marks. If it is for task for 20 marks or more than that, 10 marks, then you have to go for this calculation. Okay. The reason why we found, because we have to find what is the diameter of the pressure pad. So diameter of the pressure pad was found around 2 mm. 2 mm is very small. Since the DP is equal to 2 mm, not a standard size as per the design data book, so we go for 10 mm dia. So for 10 mm dia, from the design data book we can easily note down these values. What is D1, what is D4. So these values will be noted down based on this value 10 mm. So thus we have designed a pressure pad. Now we will go for the designing of the fixture body. That is very important. So design the fixture body, we start with the design of the base plate. So this is very important. Kindly note. So this is divided into a number of portions. So the first is the design of the base plate. We will go for the design of the base plate. So for designing of the base plate, I repeat, go back to the string building fixture. So for designing of the base plate, so this is the base plate, we have a number of things which we are supposed to consider. For example, in this case, so this is the L1 is the height of the V block. So height of the V block is L1, and this is TS also. We have to note in all these values. What is TS? This is the supporting block. These are the supporting blocks. So in between these two supporting blocks, we have the V block locators and the corresponding workpieces. So if n is equal to 5, you will be having here 5 V block locators and the corresponding workpieces. And for example, L2, so this L2, which I told you, is located between these two supporting blocks. As you can see, go back. So these two supporting blocks. So these are the 5 V block locators with its corresponding workpieces. So if this is the top view, as you can see, this is the top view. This is been more clear. So these are the 5 V block locators held between two supporting blocks. That is what is being shown here. So two supporting blocks, in between you have the V block locators plus the number of workpieces. For that, so in order to locate what is, in order to find what is the length L2, so it is equal to number of workpieces into C plus D max. So what is C? C is this value, C, height of the V block locator, plus D max. D max also we found out from this. So this is 40. So C is also 40, D max is also 40. Plus the pressure pad height H plus the clearance for loading and unloading. This may be assumed either 20 mm or 25 mm or 18 mm. This can be, the clearance can be assumed. So this is the pressure pad H, pressure pad height H may be found from this diagram. So H is 7 mm from this pressure pad. Where is the pressure pad comes? Pressure pad comes in this area, which we have already designed. This pressure pad screw clamp we have already spoken in great detail while designing jigs. So I don't need to further talk on this screw clamp with pressure pad. So this height H is quite obvious. Okay, so pressure pad height H is equal to 7 mm. So this value 7 mm, and a clearance for loading and unloading may be assumed. Then L1 is the height of the V block. So what is the height of the V block? So the height of the V block is C. So this height of the V block is C. We will go back to this. So this height of the V block, this is the height of the V block is C. Yeah, L1 is the height of the V block. So this L1. So you have two L1s. So you have two L1s on either side of the supporting blocks. Here is L1, here is one more L1, and this is L2. So if you see the length, the total length will be L is equal to, and before that the T value is equal to diameter of the workpiece D max, and thickness TS of the supporting block is should always be 1.5 times the diameter of the workpiece. So this TS of the supporting block, thickness of the supporting block will always be 1.5 times the diameter of the workpiece D max, or the you can say T. And what is the total length L? Total length L will be 2L1 plus, see this L1 plus L1 will make 2L1 plus TS plus TS. So it is 2TS plus this 2 suffix S plus L2. So this L2, and L2 we know it is N, it is number of workpieces. Number of workpieces are 5. So 5 into this value C plus D max, which will be 40 plus 40, plus pressure pad height H is equal to 7 mm, plus clearance for loading may be assumed either 22 or 18 or 20. It's up to your assumption. So total length L is equal to 2L1 plus 2TS plus L2, and finally we can find what is the total length. So the height of the supporting block should be equal to the height of the V block, which is less than the height of the workpiece. So HS is equal to A. So this HS will be this value A, 50 mm. That is this, you can call this as, that is the length, you can say. This is the length of the V block. So this is the height of the V block, this is the width of the V block. This is the length of the V block. So HS. So this height of the supporting block should be equal to the height of the now A value, I think it is given so this is the length actually. I think it is mentioned as height of the V block. So HS is equal to A value is equal to 50 mm. So you have to make a note this. So I think this is mentioned as height of the V block. Yeah, it is correctly mentioned. Height of supporting block should be equal to the height of the V block. It is correct. See, if you see from the another angle, this height may be assumed as the length of the V block. If you see from the other angle, so it is correct only. See, for example, I will repeat again. See, this can be, if you see from one angle, this is the height of the V block. If you see from this side, If you see from this side, if this is the base portion, because the V block will be located either on top, the workpiece may be kept here on top of the V block, or it can also be kept on its side. So and it can also be kept on this side. So here, so this indicates the height of the V block. Or if you see from this side, if you see if the V block is placed, if this is the bottom portion of the V block, then this side, I repeat, this will be the length of the V block. So whereas in this case, the case of string line milling fixture which we are using, from the top view, see from the top view, this is actually the height is not visible from here. So this is the top view, whereas here it is visible. So this A is correctly mentioned. So the height of supporting block should be equal to the height of the V block, which is less than the height of the workpiece. So I repeat, if you see from the other angle, this height, or if you see if the V block is located, if this is the bottom portion of the V block, then this becomes its length. Whereas in our case, in this case, since this portion will be the bottom portion, so this will be its height. So what is mentioned in the problem is correct. So height of supporting block should be equal to the height of the V block, which is less than the height of the workpiece. You know what is the height of the workpiece? It is already given. So it must be less. Fine. And assume there are 3 or we have seen here 5 workpieces. So the clearance again assumed as 20 mm. So this is the final length L. So L is equal to, so number of there is L2 is equal to 5 into 40 plus 7 plus 20, and this is 427. There is 430 mm approx. So you can find the total length by substituting these values. Fine. So the L1 is known. We know what is L1. L1 is the height of the V block, and we know what is TS is known. T is equal to 1.5 T, and L2 is also known. L2 is 430 mm. So when you substitute these values, you will be getting what is the total length. This total length of the base plate may be found out. Okay, now we will go to the calculation for the width of the base plate and supporting plate. So this HS we know, we found out. So width of the base plate is equal to 2 times the breadth of the V block. So what is the breadth of the V block? Go back to the V block diagram. So breadth of the V block is B is equal to 40 mm. So the width of the base plate will be 2 into B, 2 times of B. So this is 80 mm, and the width of the supporting block is equal to width of the base plate. Both should be one and the same. So W is equal to 80 mm. Thus we have designed, and you can also note down the bill of materials. There are some things which we can ignore. So whatever we have designed, we can just show it in the bill of materials. For example, we have designed what is a base plate, a supporting block, then supporting block, two supporting blocks we have done. So there are some things which we can skip here. There are many things are mentioned, like handle and screw. The main part, just mention the main parts in the bill of materials. Thus we have designed a string milling or a line milling fixture. The one thing which will be quite confusing for you is this portion, whether this is the height or the length of the V block. So this is quite confusing. It depends on the way we place the workpiece on the V block locator. If this is the exact position, this is how we are going to place the cylindrical component, then this could vary. So this will be the length. Whereas if this portion is the bottom portion of the V block, then this will be its height. Because sometimes some students might get confused. See, the height of the V block is C. So L1 is given as C. Then we have used A is equal to 50 mm. So it is very obvious because of the way we have placed the V block. Thanks for watching.